Hello everyone, I'm Mr. Baker and this is our third video for Unit 8. We're going to look at some cycles of matter and energy and how they work together to support life on our planet. We're going to pay some special attention to abiotic and biotic factors during this, so those living and non-living things and how they interact. So the first one is a completely abiotic cycle. It is the atmosphere. Right? You already know that hot air rises because it's less dense and cold air sinks because it's more dense. And as that happens, we are going to get things like clouds, all right? But when we combine it with Earth's rotation, which on a map looks west to east, we get these bands form called cells, right? Hadley cells are an example of this. But what I want you to know is that we get these weather patterns where large bunches of air are going to move in general directions pretty much all the time. So we, up here in North America, on this map, you can see that those red arrows show warm air moving from the subtropical highs at 30 degrees, moving up towards the 60-degree mark, right? And to the east, right? If you've seen radar as a storm's approaching, it usually comes from the southwest and moves towards the northeast, up towards Cleveland, right? Across Ohio. That's this movement of air on a large scale being realized in real time. I also want you to pay attention to these high pressure areas and low pressure areas. High pressure is where cold air is sinking and pushing down, so there's more atmospheric pressure. And hot air rising is going to give us low pressure areas. These are where there's not as much air pushing down, and so there's lower atmospheric pressure. All that combines to give us a weather pattern for long periods of time. It's going to impact climate from what we talked back in biomes, right? So air is going to move like across oceans or across water areas and bring humidity. I also want to point out that here in Ohio, we frequently get a polar vortex that pushes down into our area, right? That's the polar front that sits up there slightly less than 60 degrees on the globe here, but it pushes south as those polar easterlies are going to push down and bring cold temperatures to us for a few days to weeks in January and February. And as our climate continues to change, we're probably going to see that more often as it destabilizes some of these patterns. One of the cycles that you should know already is the water cycle. We're going to add a little bit more to that. Sorry, I skipped ahead. But I want you to understand this level of the water cycle. Right? It is called the hydrosphere when we push it to a global level, and it covers all of the water on Earth. It doesn't matter if it's fresh water, salt water, or groundwater, which you should know is present in aquifers, which are large areas underground that can store water because they have empty space in the soil. And we're not talking like giant cavern, but more like a sponge, right? Groundwater also includes rivers, lakes, ponds, streams, all that stuff. But the hydrosphere also includes water that is locked in a solid, so glaciers and snow, as well as clouds. I would like you to draw this version of the water cycle on your notes to help you kind of think about some of the bigger picture ideas that you don't normally think of when you're thinking of the water cycle, because you're probably only thinking about evaporation, condensation, and precipitation in the water cycle, but I want you to know it is a little bit more than that. Thermohaline circulation is part of the water cycle. It is the movement of water throughout our oceans. And it's going to move based on currents and temperature and saline concentration. So currents are just where the water moves normally. The temperature is hot to cold because hot things rise and cold things sink, right? Just like in the atmosphere. Saline concentration is how much salt is there. Hot water doesn't hold as much salt, and so it's less dense. Cold water holds a lot more salt and is more dense. So as it moves around the Earth and encounters things on the ocean floor like ridges and valleys, it's going to be pushed up, it's going to come back down, and we're going to get this general flow of water. With that, it also brings nutrients to different areas of the ocean so that life can be supported. A lot of the areas that we do a lot of fishing in are where not hot, warm water is coming up from the ocean depths and bringing nutrients with it. So we get a lot more fishing available because there's more life there. Right? You may also note the current of warm water that flows from south to north along the coast of the Americas and a cold band that goes north to south across the Atlantic as well. That's going to be very evident in your history studies of slave trade, right? We see ocean exploring throughout the Indian Ocean and Pacific Ocean being informed by these thermohaline currents, right? It's a large movement of heat and salt water throughout our oceans, right? The carbon cycle is another one, as we've got this flow of carbon dioxide across our autotrophs and heterotrophs and interacting with things like auto and factory emissions and fossil fuels, right? Again, I want you to draw this just to help you think more about some of those things. We have talked about this a lot all year, so we're not going to push too far into it. The nitrogen cycle is similar, but a little newer, right? Denitrification and nitrogen fixation are two halves of the cycle, right? Denitrification is the pulling of nitrogen out of the cycle into a gas, while as nitrogen fixation is turning that nitrogen gas back into forms that can be harnessed and used by organisms, right? So a lot of this is done by nitrogen fixing bacteria, which are going to take that nitrogen and turn it into ammonia, right? Or ammonium, NH3 and NH4, right? It's also done by lightning, though. When lightning strikes, this happens naturally. Bacteria can also turn ammonium into nitrous oxide, NO2, right? And through nitrification, that could become NO3, which can be used by plants and be brought up through their roots, right? The plants are eaten by animals, and that nitrogen can flow into our consumers, our heterotrophs, which then can be put back into the soil through waste or decay. This is going to be a life supporting cycle. So, of the ones that we just covered, I want you to tell me in at least one sentence which of the cycles are completely abiotic and which of the cycles are biotic and abiotic, which ones have living and non living things working together. I mentioned how some of these can be disrupted. I want you to know a few ways that these cycles are disrupted quite often, right? The water cycle can be disrupted by changing where the water goes or by limiting the amount of water that can be evaporated. Thermohaline circulation is going to see interruptions as temperature changes in the water and as there's more CO2 being released into the atmosphere versus taken up because it's going to be stored in the water as aqueous carbon dioxide, right? Or frozen in glaciers. The carbon cycle is going to be interrupted by global warming as things are living and dying differently, right? And as biodiversity decreases, we're going to see less organisms to be participating in the carbon cycle. The same thing will affect the nitrogen cycle, but we're also going to add soil and river acidification as the higher acidity is going to affect the bacteria. Right. That wraps up our section on abiotic and biotic cycles for the Earth and how they can kind of interact. Make sure you've got those diagrams written down. And if you've got questions, as always, make sure to bring them in. I will see you in class.